All right, this is section 10.4, day 2, and this is after the video. Find the interval and radius of convergence. Here we have a variable in the problem, and this would be geometric if we didn't have that n right there. Because we have that n, we're going to use the ratio test. We have the limit as n approaches infinity of n plus 1, so we have x minus 2 to the n plus 1 over n plus 1, and then 2 to the n plus 1. Now we're going to divide by the nth term, but we'll multiply by the reciprocal. 2 to the n over x minus 2 to the n. We have the limit as n approaches infinity of absolute value of there's one extra x minus 2. There is an extra 2 in the denominator. And then we have n over n plus 1. Now the limit as n approaches infinity is 1. We have the absolute value of x minus 2 over 2 has to be less than 1. So negative 1 is less than x minus 2 over 2 less than 1. We'll multiply by 2. Negative 2 is less than x minus 2 less than 2. And then add 2. 0 less than x less than 4. The interval of convergence. Well, right now it's from 0 to 4, but let's check the endpoints. Let's plug 0 in here. And when we plug 0 in here, we get negative 2 to the n. What do we get? We get n equals 1 to infinity of negative 1 to the n plus 1. And we get negative 2 to the n over n2 to the n. Well, these are going to cancel out, but it's going to leave a negative, which means this is still going to alternate, except when n is 1, this will be positive, but then that negative will make it negative. So it'll alternate, but it'll start with a negative. This becomes n equals 1 to infinity of negative 1 to the n plus 1 over n. Now, 1 over n, this is the harmonic series. But then if you include this is the alternating harmonic series. And the alternating harmonic series converges. So far 0 is good. This converges at 0. Now if you plug 4 in, this is still the alternating harmonic series because we get negative 1 to the n plus 1. Now, when we plug 4 in, we get 4 minus 2 is 2. We get 2 to the n over n, 2 to the n. Well, now those are going to cancel. And like I said, you get the alternating harmonic series. And for now, just know that the alternating harmonic series converges. So the interval of convergence is from 0 to 4. The radius of convergence is half that. So the radius of convergence is equal to 2. So imagine a number line. Here's 0. Here's 4. Here's 2. That's right down the middle. And so the radius goes from the middle to the edges, and that's 2 units either way. So the radius of convergence, like I said, is 2 for this one. Find the interval and radius of convergence for this one. All right, let's go with the ratio test again. Limit as n approaches infinity. The factorial is a dead giveaway that this is going to be a ratio test. This is going to be x to the, well, if you plug n plus 1 in for n, you get 2n plus 2. 2n plus 2 over, this is going to be, if I plug in n plus 1 for this n, that's going to be 2n plus 2. We get 2n plus 3 factorial. And we're going to multiply by the reciprocal. So 2n plus 1 factorial over x to the 2n. Let's see what we have left. Limit as n approaches infinity. We need to figure out what do we get when we can cancel what we can cancel here. Well, we can write this as 2n plus 1 factorial over 2n plus 1 factorial times 2n plus 2 times 2n plus 3. And we can get the factorials to cancel that way. Well, now we have an extra, let's see, 2 extra x's up here. X squared, and then over 2n plus 2, 2n plus 3. Now, if we take the limit as n approaches infinity with the n's, we end up with 0. We get 0 times x squared has to be less than 1. Well, 0 times anything is always less than 1. So the interval of convergence is from negative infinity to infinity, because anything works. And the radius of convergence is infinite. And that's what happens when you're left with all the n's just in the denominator. Find the interval and radius of convergence. We have the limit as n approaches infinity of, let's go with n plus 1 factorial, x plus 1 to the n plus 1. And then we'll divide by n factorial times x plus 1 to the n. We have n factorial on the top. N factorial times n plus 1 is still n plus 1 factorial over n factorial. Those cancel. We're left with limit as n approaches infinity of absolute value of n plus 1. And there's an extra x plus 1 here. Yeah, just an extra. Got it. Now, if we take the limit as n approaches infinity, this is going to be infinity, and then times x plus 1. And we want that to be less than 1. Well, the only way that this could possibly be less than 1 is if we take 0 times infinity. So let's see. The interval of convergence is negative 1. That's what makes this 0. And the radius of convergence is 0. There's only one number that can possibly work. When the n's are left on the top, you're going to get infinity, and you got to make this equal to 0. Find the interval and radius of convergence again. This one is actually geometric. R, what we're multiplying by each time, is x squared minus 1 over 3. And with geometric series, we want the r, absolute value of r, to be less than 1. So we have not r here, but x squared rather. X squared minus 1 over 3 is less than 1. And I suppose we could use the definition. Negative 1 is less than x squared minus 1 over 3 is less than 1. We could multiply by 3 is less than 3. And then we can add 1. So negative 2 is less than x squared is less than 4. But x squared is always going to be bigger than negative 2. So we can kind of get rid of this. We don't need that part. Now there's a couple ways to solve this one. In order for x squared to be less than 4, x has to be less than 2. That means the interval of convergence is going to be actually the absolute value of x has to be less than 2 when we square root. So we're looking at negative 2 to 2. And the radius of convergence is equal to 2. Now, another way to look at this is we have x squared minus 4 is less than 0. You can subtract 4 over. This factors x minus 2, x plus 2 is less than 0. And if we were to graph these, if we were to graph this quadratic, we'd have negative 2 to 2. Well, this quadratic is an upside, or not, it's a parabola like this. And we want to know where that parabola is less than 0. And that, again, is between negative 2 and 2.